started. So today we're going to start off with statistics, but I just want to make sure that we have the graph under lock and key here, basically, that we understand it properly. So when you have graph paper, there are two types of graph paper, but the most popular one is the 1 centimeter types of graphs when they go in most stores. And there's a real easy way to know whether you have the 1 centimeter type of graph paper or the 2 centimeter types of graph paper. You just take your ruler and measure the length of all the blocks, right? So clearly we could see here that each block is 1 centimeter. We can see it here. It goes from 1 to 1, even on the y-axis. Now, I need for everyone, get your ruler and confirm that every block, whether it's on the x-axis, is 1 centimeter or not. Some people, the first block is actually 2 centimeters, right? And you will notice that in the most popular type of graph paper, the 1 centimeter, you just have 5 small blocks in between. Look at there, 1, 2, 3, 4, and 5, okay? Confirm everything, because you have to be super accurate today. Today we go, if your answers, it has a decimal in it, I need to see that decimal, right? We're going for perfection here today, right? Great. Right. So the thing about it, most graph paper, well, not all, right? Well, in the exam, the examiner is supposed to give you the scale, right? So let's just do some quick calculations here and try to figure out how much each small block is worth. Now, if I come and tell you on the x-axis, right, you'll see it written somewhere that on the x-axis, the scale, the examiner says, hey, the scale is 5 units, right? 5 units represent 10. Sorry, 2 centimeters equals 10 units. Let me just say you open your exam paper and you see that. All right. So this is the x-axis they're talking about. So here's 0. What they're already saying is that every 2 centimeters, remember on my graph paper, every block you see in here is 1 centimeter. So they said every 2 centimeters, 1 centimeters, 2 centimeters is 10 units. That means every 2 centimeters would be another 10 units, so 20. And of course, over here would be 30. Now, the question is, right? The big blocks, or putting these measurements, is easy. Common sense should say that if from here to here is 10, then exactly in the middle will be half the amount. So here would be 5. Over here is 15. Over here is 25. That should be easy to reason out, okay? But my question now is, how much is every small block worth? Like, how much is this worth? How much is this worth? How much is this worth? That could get a little tricky in the exam. Now, I know in the homework I showed you, but let's just revise it, right? What we need to do to figure out the value of every small block, you have to take the value of each block. So each big block, we reason out it was 5. So the value of each big block is 5. And then you have to count the amount of small blocks it took to make that. So it have 1, 2, 3, 4, 5. So it just so happens we have 5 small blocks. So 5 divided by 5 is 1. Now, I know a lot of you are saying, well, this easy, this easy. It's going to get a little bit more complicated. So that means here's 1, here's 2, here's 3. Sorry, I put 4. Here is 3, and over here is 4, and finally 5. So the value of each small block is 1. That means here will be 6, 7, 8, 9, and you all get the picture. Now, in the homework, right, sometimes when you're plotting points, sometimes the examiner does ask you to do what? Plot decimals, right? Remember that. So if he asks you to plot to find 11.5 on the x-axis, we're talking about the x-axis. Remember, if here's 10, over here would be 11, the next one will be 12. Where would 11.5 be? Do we all agree that 11.5 will be exactly in between the 11 and the 12? That means you must have a real sharpened pencil. Your pencil can't have a real thick point, right? Because you have to go in between exactly 11 and 12, right? Now, a lot of people think because it's a 0.5 that you will always have to go in between a small block. In today's question, you had to go in between what? A small block to get the 0.5, right? But will it always be like that? No. And I'm going to show you an example where you don't have to go in between the small block. Let's just use the y-axis as an example. Let's say now, they say that the scale for the y-axis, just to answer one of the most popular questions. In the same question, does the x and y axis have to have the same scale? And the answer to that question is no. They can have completely different scales if they want. Now, if the examiner comes and says on the y-axis, every 2 centimeters is 5 units. So we're going on the y-axis, right? So every 2 centimeters is what? 5. So here's 5, another 2 centimeters is 10, right? How much is every small block worth? Now, we know in between is going to be half, right? Like over here is going to be 2.5, over here is going to be 7.5, right? But even so, right, well, once you reason that out, how much is every small block worth on the y-axis? What's the value of each big block? Each big block is what? 2.5, right? Right? How much and every what? How much small blocks we have between the 0 and the 2.5? 1, 2, 3, 4, 5. 5. So how much is every small block worth? How much is every small block worth? If you take 2.5 and divide it by 5, you're going to get 0.5. So look at this, right? So that means every small block is worth 0.5. So if here's 0, here's 0.5, 1, 1.5, 2, 2.5. So where would 11.5 be on the y-axis? Well, if here's 10, here will be 10.5, here will be 11, and finally, this block exactly would be 11.5. Did we have to go in between a small block in that particular case to get 11.5? And the answer is no. So you see, 0.5 doesn't always mean exactly in the middle. And the examiner is going to look for these things. I know a lot of students, and I made this super clear in the homework, right? I've made it super clear that when the examiner says he wants something 0.5, he wants exactly 11.5 or 10.5. If you try to round that off to 12, like you say 11.5, if I round it off to the nearest whole number is 12, and you put that 12, minus in marks, okay? So no rounding off in today's question. So guys, we're going to move to the first question. I'm going to give you all 20 minutes. I'm going to provide some hints, obviously, within the question, right? Right? And you're going to work it through. And of course, as you work through the question, like if you have a part A or part B, keep me updated. You finish part A, what's the answer? What you got? I just finished part B, what's the answer? Right? Let's go. The first question is a cumulative frequency question. You have 20 minutes because literally in the exam, you're going to have no more than 20 minutes to do this entire question. Good luck and keep me updated on your progress. Wrong, right? So I hope you all remember to find the upper class boundary and the lower class boundary. You will need it eventually, right? Now, I know to ask you to complete the cumulative frequency part for the time being. Remember how you complete this. Like the first one here is 2. But to get the next value, you take the 2 and add it to the next value just below. So 2 plus 5 is 7. Then you take the 7 and add it to what? The 8. Everyone going correct so far? You're getting those values correct? And then you take the 15, well, right? Great. A lot of people typed out the answers and whatnot, right? So that's good. That's good. Okay. Let's see if you all got the first part correct. These are the values I got when I worked out the cumulative frequency. I will just circle the important values. The 2, 7, right? So I trust a lot of people had these values already, right? So it goes from 2 to 40, right? Also, I hope you all remember to find the upper class boundary. Well, when you're plotting the cumulative frequency, it's the upper class boundary you need. So how much people got, you remember you had to add, well, in today's question, you had to add 0.5. Great. So, right? So make sure you have the 0.5s going on. These values are going on the x-axis, and these circle values are going on the y-axis. Don't worry, guys. I'm going back to the next slide just now. I know some of you will want to see the questions. I just wanted to make sure that you have this down. First, for those who have any wrong values, just take out 10 seconds, take down what you need to take down, and I'm going back to the previous slide so you can see the questions from A to E. All right? Don't worry, I won't do you all. Great. So we went through this already. So what we have to do now, right? Remember we plotted the upper class boundary against the cumulative frequency, but the examiner gave us the units here, right? Right? The examiner gave us the units here. I mean, the scale. On the x-axis, they said every 2 centimeters is equal to 10. So here is 0. So I already have my rulers. I think they make it easy for you guys. So every 2 centimeters is 10. So what the first 2 centimeters is 10. The next 2 centimeters is 10. And the next 2 centimeters is 10. Which means I could easily reason out here's 5, here's 15, and here's what? 25. Okay? So that means every small block, if I take 5, because every big block is what? 5. And how much small blocks it have in between? 5. So I think I went through this already. You'll get 1. So that means every small block is 1. So I think one of the first points on the x-axis is 10.5. Is that I think that was one of the first values. So if here's 10, then over here, the next block is what? 11.5. If here's 10, over here, sorry, over here is 11. My mistake, what nonsense I'm talking. If here's 10, the next one is 11. The next block is 12. So that means if you're looking for 10.5, you had to make sure and squint your eyes and get a really good pencil to go in between the 10 and 11 to approximate the 10.5, okay? So that was the scale for the x-axis. For the y-axis, they told you every 2 centimeters was 5. All right. So every 2 centimeters is 5. Here's 5. Here's what? 10. So for the x-axis, we know if here's 5, then here's 2.5. Over here will be 7.5, right? It is just the midpoint. So every small, big block is 5. And we have 1, 2, 3, 4, 5. So, no, sorry, my mistake, guys. Every big block is 2.5. Thanks for correcting me. 2.5. So that means every small block on the x-axis is 0.5. Now, this is going to confuse some people because I think all the values on the y-axis are whole numbers, right? If you look at your cumulative frequency values, that's the third column. Every value there is what? A whole number. And remember, every small block is what? 0.5. So here's 0.5, here's 1, here's 1.5, here's 2. So that means every two small blocks is a whole number. So if here's 0, 2 blocks is 1, and next 2 blocks is 2, and next 2 blocks will be 3, and next 2 blocks will be 4, and then finally you'll get 5. So you're counting in 0.5s on the y-axis. And you have to get it super accurate because keep in mind, that is all the person who correcting your paper, that is all he doing whole day, day after day. He's going to spot the tiniest mistake there is. And there will be no mercy. All right. So how much of y'all think you did a really, really good job at plotting the graph? I will show you my graph in a little while. How much of y'all think you bypass all of those tricks, those 0.5s and whatnot? All right. So here what? Before I move on, right, just give everybody a few seconds, take a half a minute. See if we can correct all your mistakes, and then we're going to correct the rest of it. Let's see how my graph looks. Now, I use a computer to do it, right? So it doesn't look like a very smooth curve. So I guess you would minus 1 point from me. How much of it looks something like this? Now, it's hard to see my 0.5s and whatnot, right? But that's the general shape of the graph. Let me know if you have something seriously resembling that. I know this looking like 10, but this first one's supposed to line up with 10.5, right? The computer didn't do a good job at making it look super, super accurate. But I guarantee you, if I had zoomed in to the graph, you would have seen the 10.5 and the 20.5 and the 30.5 exact, right? Should the graph connect to the origin? Like, should you complete the graph to the origin? What do you all think? Should the graph be connected to the origin as a complete? Should it go back to 0, 0? The answer is yes, it should be. So that's my mistake. So everyone put it back to touch the origin. Put it back, put it back. It's not going to affect your results. It's just that if you have a real fussy examiner, he might stoop and say, I'm going to take away something, right? But the thing about it is not even going to affect your results. Okay, so let's move on, right? Let's move on. Estimating the median. So another word for median is middle. And another word for median is second quartile. Second quartile. So the examiner could use any of those phrases. He could say find the middle value, the median value, or the second quartile. Also, the symbol for second quartile is Q2. So how do you find the median? Well, I have the formula here. This is the most accurate formula. Now, I know some textbooks, instead of having n plus 1, they will just have n divided by 2. Take my advice. The better formula is n plus 1, where n is the amount of people in the survey. How much people took this test? Because I think we're measuring the marks in a test. How many people were involved in this test? 40, right? That it's usually the highest used value on the y-axis, or the last value in the cumulative frequency. If you look at your cumulative frequency column, 40 is the last value. So to find the medium, or better yet, the step to find the medium, the first step is to say 40 plus 1 divided by 2. Now remember, I know I say this in every single math class. When you have something on top and you want to divide by the underneath, before you press the divide, make sure and press equal and then divide by 2. Or you can put the top in brackets so the calculator knows it's dividing the whole top by 2. So let's work this out. 40 plus 1 divided by 2. I got 20.5. Quick question. Is that 20.5 the final answer for the median? If I put 20.5 as my final answer, will I get it correct? And the answer is no. Based on my tone alone, you know that the answer to that is no. This 20.5 allows us to find the median. So what you have to do is go on your y-axis and look for exactly 20.5, right? You're looking for exactly 20.5. Now, if I recall correctly, on the y-axis, every small block was 0.5, right? So look for 20 and go one small block directly above that. That would be exactly 20.5. You won't need to go in between a block. To get the median now, you draw a straight line from here. Well, yours is going to look better than mine, right? And it's going to hit the graph. And wherever it hits the graph, you drop it straight down. And the value it falls on is the median. Now, I'm not too accurate here, but on my graph, it's looking like 36 or 35. Anybody could confirm the actual answer? It's not going to, I don't think it's going to be 30. I think it's going to be, it can't be 30.5 because I'm not too sure why someone said 30.5, right? Remember, if here's 30, every small block I think was 1, right? So here was 31, here was 32, here was 33, here was 34, 35. So the examiner is going to be a little bit lenient, you know how? Because everybody has a different hand, right? When you draw in that curve, and everybody going to draw the curve slightly different. So the examiner is going to have a range. So the median, anything between 35 and 36.5, I would consider it correct. And you have to put the word marks after because that's the median mark. How much people got between 35 and 36.5? I think 37 will be a little, okay, here, to be fair, anything between 35 and 37, including 35 and 37, I'm going to consider it correct. How much people took home the marks for that question? They got anything between 35 and 37, right? Great. People keep me in the loop. Right. Part D. Find the interquartile range. To find the interquartile range, you have to find the Q3 value and the Q1 value. This is third quartile and this is first quartile. For those who didn't know what to do, I'm giving you the formulas, right? What you need to do is replace the n with what? 40. And do the same thing. Go across and come down for both of them. Both of them will give you a different value. For the interquartile range, you take the final value for Q3 and minus the final value for Q1. So for those who didn't know what to do, I've given you a minute, all right? Let's find Q1. So we're going to replace the n with 40. So we're going to say 40 plus 1 divided by 4. 40 plus 1, that's all right. 40 plus 1 divided by 4. This one has a, anybody got 10.25 to assist us in finding the Q1. Now, 10.25 is not the actual Q1 value. You have to try the best to find 10.25. Now, you're going to have to go in between a small block, right? Because remember, every small block is 0.5 on the y-axis. So to get 10.25, which is half of 0.5, you got to go in between a small block, right? I know that's real torturous, but the examiner will look for that. So you go across and then you come down. What value did it, on my one, it looking like close to 22 or 23. I'm just going to say it's close to something around 22 or 23. Anybody could agree with that? 22 or 23, right? I'll accept any one of those values. Anything in between 22 or 23. But I know it has to be something real close to that. Let's go to the next one, the Q3 value, right? 40 plus 1 multiplied by 3 divided by 4. Let's work out that. 40 plus 1 multiplied by 3 divided by 4. I got 30.75, but that's not the actual Q3 value. You're looking for, as best as possible, 30.75. That will be 1.5 blocks above the 30, because the first block above the 30 will be 30.5, and the next one will be 31. You have to go in between the 31 and 30.5, right? I know it's headache. I know it's headache, right? But you have to be exact. And then you go across, hit the graph, and let it fall, oops, down. And that looking like close, the Q3 value looking like 47 or 48. That looking all right. I think that should be 46, so between 46 and 48. I think that's reasonable to assume. So to get your final answer now, you take whatever final answer you get for Q1, and you take whatever final answer you get for Q3, and you minus it. Everybody's going to get slightly different answers. So I'm just going to send an approximate answer here. I think your answer should be close to 25, your final answer, marks. Right? So I know you might, I think 21.5 is too much off, right? Rahul, check that now. Samia, check that back now. So, right. Estimating the number of students who passed. Refresh my memory, guys, because we are a long way from the first slide. How much was the pass mark again? Well, what was the pass mark in the exam? Did they tell it was 35? 35 was the pass mark? What kind of exam is this? You can get to. You sure? Let me double check that. 35. That would be real great, right? If in real life the pass mark was 35, right? All right. So to pass the exam, you need 35 marks. So here's the thing. Remember, it have how much people who took the test? 40. I'm just putting it here. Students. That's the amount of students who took the exam. The pass mark is 35. So everyone, this time you're starting off on the x-axis. Look for 35. Because that's the pass mark. You're supposed to go straight up. Wherever it hits, go straight across. Now, we fall on 20 students, right? Just do that for me. In case you didn't do it, look for 35, go up, let hit the graph, and then go to the left. So it falls on 20 students, right? It falls on 20 students. Now, and some people might have 18 or 19, right? But anything close to 20, you record whatever you get, right? Now, here's the thing. To pass the exam, right, you need to get more than 35 marks, right? To pass the exam. Also, when you read a value of the cumulative frequency axis, the y-axis, does it give you less than info or more than info? I mentioned this in the homework. Turn back in your notes. When you read in a cumulative frequency question, when you read a value of the y-axis, does it give you less than or more than info? Guys, stop guessing. Turn back in your notes. It's have to be in your notes somewhere when you were doing cumulative frequency, because I made a special note about that. I was real precise about that one. It always gives you less than info, right? You see how much people got it wrong. So I suspect a lot of people here don't have the notes. So you're guessing, because if you made notes and you turn back in your notes, you would have seen that it was less than and not more than. Okay? So a lot of people are selling out themselves here that they didn't do the homework. Okay? Great. So how do we interpret this? How do we interpret this? That means 20 people, or in some people cases, 18 or 19, 20 people got less than this mark. That is how you interpret it, okay? So, okay, a lot of people are telling me that, well, more people are telling me, sorry, and let me just adjust my answer, right? More people are saying they're getting 19 than 20. I'm going to adjust it, right? So the value it falls on is 19, not 20. Let's just go with that. I use a 19, right? Great. That means 19 people got less than 35 marks. Quick question. If the y-axis only tells us less than, okay? Did those 19 people pass the exam or fail the exam? Try. I know the grammar could be a little tricky. Let me read back that sentence. 19 people got less than 35. Right, this 19 people failed. They asked who passed. Now, don't get me wrong. If they ask how much people failed the exam, well, the answer is 19. All right? So how much people pass? If it have 40 people in class in total and 19 fail, how much pass? 21, correct. It's 40 minus 19. So you see, whenever I ask you, whenever it's a more than question, you just have to minus it from the total, because technically this is a more than question. Because to pass, you need to get more than 35. Okay? All right. All right, so we have a class both here to do, right? We have a class both here. So how much people are hungry here right now? Or they have food in front of them? What's your situation right now? Right? All right, so we're going to take a vote in class, right? If you're hungry, you're probably not going to like this question. Which one do you think seems yummier right now? If one can, I'm talking about right now, I'm not talking about in general. Dig into your feelings right now. Which one would you prefer to appear in front of you? A piping hot chicken roti or goat roti or soy or whatever, right? Look how yummy that looks. Or a zinger combo, right? Let's take the vote. I'm showing my son here how the voting looks there. First time you've seen it. Take your vote there, guys. Take your vote. This one is actually a very close call. All right, 7 more people to vote, right? This one was really close, guys. Let's share the results. Let's share the results. I'm going to end the poll, right? Right. So we're playing for points. The more popular vote was KFC, but it didn't win by too much, only by 10 people, 57% versus 43%. I personally feeling for that roti. That's what I'm feeling for right now. So for everyone who chose the Zinger, the KFC combo, put 10 points. You're going to keep track of points. For the people who chose the roti, 0 points. If I track it will make the class go a little bit faster. KFC people, 10 points. Let's go. Let's move on. Right. Histograms, right? Histograms. So what's going on? The histogram is the one with the building blocks, okay? Everyone has, look at the scale, everyone has 20 minutes to do this entire question. Good luck. Histograms, it's completely different from the cumulative frequency. And please don't forget to find the upper class boundary and the lower class boundary. So I hope everyone, when you were doing how you call it, the graph, you remember to put the upper class boundary and the lower class boundary. So you're supposed to add 0.5 to everyone on this side, right? Right? In the homework, I showed you how to get the 0.5. Now, what you're supposed to do with everyone on this side, you're supposed to minus 0.5. So you're going to get minus 0.5, 2.5, 5.5, 8.5, 11.5, and 14.5. Okay? Now, I know we're going to have a negative value here. But do you actually need to put in the negative value? Because your graph paper is only going to have positive values, right? So that means your first value, your first rectangle, would actually start from 0 and end where? At 2.5. The rest of them will go from 2.5 to 5.5 or 5.5 and to 8.5. How much people but if you just extended the x-axis backwards a little bit to accommodate the minus 0.5, the examiner will have no problem with that either. So which one did you all do when you all were doing the graph? Did you all start it at 0, or what am I asking, or did you start it at minus 0.5? Either way, it's correct. Either way, it's not going to make a big difference. Okay? All right. No problem. Some have the classes divided. No problem. Let's, and by the way, I think some people think it have a cumulative frequency. No. The graph, these are the actual Y values. These are the actual Y values. So let's go to the scale and let's make sure everyone had the scale correct. They said 1 centimeter equals 1 unit on the x-axis, and on the y-axis, 1 centimeter equals 1 unit. So for both of them, it's 1 unit. So let's see if you got it correct. If this is your graph paper, here was 0, every 1 centimeter was 1. over here too. 1, 2, 3, 4, 5. So both axes happen to have the same scale. Right now, for this one here, if you needed to find 2.5, right? Let's go on the x-axis. How much is each small block worth? Every big block is 1, and every big block has how much? 5 small blocks. So that means every small block is 0.2. How much people were actually able to reason that out? So that means here was 0.2. Here was 0.4. The next one was 0.6, 0.8, and 0.1. You have to get it accurate. Every small block was 0.2. Well, let's check something on the next one here, right? So the first block had to go from 0 to 2.5. Where would 2.5 be? If here's 2.2 and here's 2.4 and this one here is 2.6 because we counted in 0.2s. Must start back again. 2, 2.2, 2.4, 2.6. Won't 2.5 be exactly in between 2.4 and 2.6? You would have to go in between a small block to approximate that 2.5. I hope you all got that. Anybody just need some time to correct it? All right, so here what? Give everybody a few minutes. Just 2 minutes. All I'm asking is 2 minutes because I really wanted to build confidence in everyone here. For those who didn't approximate those 0.5s correctly, I'm going to give you 2 minutes to at least erase what you have, draw it back neatly, and we will continue with the question. For those who finish with the question, you can take a small break. Go get something to eat, get something to drink, and come back in 2 minutes. Okay? All right. We went through this already. Did your graph look something like this? Look at my shape. I know you're not going to be able to see the 0.5s very, very clearly, but you notice the first one starts at 0 and ends exactly in between the 2 and the 3, makes it 2.5. The next one starts at 2.5 and ends at 5.5. You notice there's no spaces in between the blocks. No spaces. If you have any spaces, it's wrong, right? Or partially wrong at least. All right. Right, anything here? Right. The first thing they want us to do, the question did change in part B. They want us to identify the modal class. Now, they're not asking us to use the graph just yet. Modal class just means the category here that has the highest frequency, right? Yeah. Right? Which one has the highest frequency? This one has the highest frequency, right? 9 to 11. So you just have to physically write 9 to 11. Okay? They ask for the modal class. That's the actual answer. Right? Nothing to, I think some people went to the graph by mistake. That's all, guys. That's another message. Right. Let's move on. What's the next part? Part C. By the way, I just want to point out something. I know I didn't ask this. If instead they ask us to, instead of finding the modal class, they ask us to identify the mode. They just said mode and not modal class. They just said mode. How would you find the actual mode? Well, I want you all to try this question. It's an additional question now. If they ask us for modal class, the answer is 9 to 11. Mode calculated using the graph and send it to me. You'll need a graph in order to get it. To find the mode, fine. We look at the tallest bar. That's our first step. But the tallest bar will be bordered by two shorter bars. The one to the left touches the taller bar over here. So I'll point a pink dot. This is where the shorter one on the left-hand side touches the taller one. And the one to the right, that shorter block, touches it over here. Okay? What you need to do is draw an X. You're going to, from this side, you draw an X to touch the other side. And from on this side, you complete the X by making it touch the other side, which I showed you in the homework. Where does the X meet? The X meets over here. Where the X, the funny looking X meets, you drop it straight down. Anybody can tell me what it's falling on? To me, that looking like 9.5 or not 9.5. That looking like 9.2 or something like that, or real close to 9. I think the mode will be close to 9.2 because every small block is 0.2, right? 9, 9.2, 9.4. So around 9.2, 9.4, I guess it's somewhere around there. Or 9.3 or something like that. That is how you find the mode. The mode and the modal class is two different things. By the way, back to the first question, I want to clear up something. When they ask you to find the modal class, do we put the 9 to 11 and put the 12? Or do we just put the 9 to 11? Well, which one? Do we put both, the 9 to 11 or just the 9 and to 11 and the 12? Correct, it's just the 9 to 11. The class is the 9 to 11. The 12 is the frequency. That's different from the actual class. All right, let's move on to the next question. How much of y'all didn't know how to do this question? They asked it based on the answers sent. I only saw a few correct answers, or what I think is the correct answer. For those who didn't know what to do, I'm giving you a jump start. I'm giving you back the homework, the formula you need to use. I even laid out how to lay out your table and everything. Take a 3 minutes, right? Take a 3 minutes and see if you can produce the mean of the information. Midpoints. How do you find the midpoints? You add the two values and you divide by 2. 0 plus 2 and you divide by 2. Then you say 3 plus 5 and you divide by 2. How much people got those values for the midpoints? You have to, whenever they give you a range, the first thing you have to do is find the midpoint when you're trying to find the mean. The next thing you have to do, the formula says, take f and multiply it by x. So you're taking the frequency value and multiplying it by the midpoint value. The midpoint value is the x value. So you're going to say 4 by 1 is 4, 7 by 4 is 28, 10 by 7 is 70, and so forth. How much people got those for the fx value? Great. So now the formula says we have to add up or sigma the fx, the f multiplied by x column. When we add up everybody in the fx column, when we sigma the fx column, how much did you all get? Let's add it up. 4 plus 28 plus 70 plus 120 plus 65 plus 32. I'm getting 319. Can you all confirm that? Great. So the sigma fx is 319. And now we have to divide it by the sigma f. So let's divide it by the sigma f. Sigma f is regular, boring frequency. Abigail, check it back. Everyone else is getting 319. Sometimes you just adding it up. You know exactly what to do. It's just you're tired. So you make a real simple mistake. But it's 319. Okay? When we add up the frequency, 4 plus 7 plus 10 plus 12 plus 5 plus 2. I'm getting 40. Anybody? Well, yeah, real people getting 40. The underneath is 40. Divide it and you finish. 319 divided by 40. 7.975. I know you're going to round it off to 2 decimal places, which is what you're supposed to do. Hours. Let's move on. Right, another question. Is it okay to round it off to 8? Because 7.98 is close to 8. The answer is no. 2 decimal places. 2 decimal places. Don't make that mistake in the exam. Right. So, percentage of students who studied at least 9 hours, right? So, at least 9 hours. Does that at least 9 hours means what? Think about it. When people hear the word least, they normally think what? Less than, right? They normally think less than, right? But at least actually means more than. And I'm going to prove it to you after this talk money, the thing everybody understands. If I ask you for at least $9, is it okay to give me less than 9? I said at least. So that means I want 9 or more. All right? 9 or more. So how much people that have in all? I think we know it have 40 people in all. So how much people studied at least 9 hours? And 9 to 11 hours is at least 9 hours. And 12 to 14 hours is also at least is more than 9. And 15 to 17 hours fits the category of at least 9 hours. And the frequency is the amount of students. So how much students in all studied at least 9 hours? 12 plus 5 plus 2, which is how much? 19 students. So 19 students, I'll put STU, right? But that's not the end of the question. They want you to convert it to a percentage. How are you converting that 19 to a percentage? 19 divided by 40 multiplied by 100%. Let's see the percentage here. But calculate the percentage and send it on the chat now, right? 19 divided by 40 multiplied by 100, I'm getting 47.5%. Right? Right. Probability. How much people didn't get a chance to work out this one here, right? Probability that a randomly chosen student studied between 6 to 8 hours. Okay? Now this one here, how much students studied between 6 to 11 hours, right? 6 to 11 hours, from 6 all the way to 11 hours. And the total amount of students who studied between 6 to 11 hours is 22. And that makes sense? How do you convert something to a probability? To convert something to a probability, you just take the amount you are concerned about. So 22 people, right, fit the criteria of studying between 9 to 6 to 11 hours, and you just always divide it by the total. You don't have to multiply this one by a percentage, by 100. Probability is just the amount you're concerned about, which is 22, and you always divide it by the total amount you have. How much people were able, before I did it, were able to get 0.55? Right. But if you didn't know, I hope you get it correct now. You can put it as a fraction too. If you left it as 11 over 20, like you simplify it to 11 over 20, that correct as well. Right. See, y'all deserve a relaxer here. Okay. So here's the scenario. You are a big time movie executive, right? It's the summertime. You know, the summertime there's always release some blockbuster movie, but your studio can only release one movie. Which one do you all think looks more interesting? Watch the posters and read the storyline for each one, and then we're gonna vote. Give you a few seconds to read it there. It seems that Bee's Adventure only won by 2 votes, right? Me personally, I would have chosen Bee's Adventure as well. All right. So the Bees people put 10 points. Stripes people who voted 0 points. All right. Let's go. Right. Next question. Frequency polygon. Get your next graph paper ready. Get started. 20 minutes again. Part E, for this frequency polygon, we need to do what? They said complete the table. When you all completed the table, I highlighted it kind of off yellow there. How much people can confirm they got that for the midpoint? Make sure you get it exact. Make sure you get it exact. Right. Next thing we have to do, right? That's easy, right? So the next thing we have to do is get the scale correct. So let's get the scale correct here. They said on the x-axis, every 2 centimeters is 5. All right. Every 2 centimeters. Here's 0. 2 centimeters is 5. Next to 10. Next to 15. And on the y-axis, every 1 centimeter is 2. So here's 2. Here's 4. Here's 6. 8. Now y'all get the idea. How much people got the scale correct so far, right? Because if the scale wrong, the examiner going to take away points, right? Good. Let's work out the x-axis first, like the value of each one. So if here is 5, then in between here is 2.5, and here would be what? 7.5, right? On the x-axis, every big block is 2.5, and it have how much? 1, 2, 3, 4, 5. So that means on the x-axis, every small block is 0.5. 0, 0.5. 1, 1.5. 2, 2.5. You all get the idea. On the y-axis, okay, let's calculate the value of each small block. So every big block is 2. And how much small blocks? 1, 2, 3, 4, 5. That means every small block on the y-axis is 0.4. 0.4, 0.8, 1.2, 1.6, 2. But I don't even think, because all the y values are going to be whole numbers in any case. So this won't be too necessary, right? And I'm not even too sure if this will be necessary, but we will see. We all on the correct track there, guys. Everyone was able to resolve the value of every small block, right? Right. Great. So people are saying, yes, let's move on. Let's move on. Now, to me, the frequency polygon is the easiest. All we supposed to do, well, the midpoint goes on the x-axis and the frequency goes on the y-axis. All you have to do is plot the points. You don't even have to draw any bars or anything like that. So the first one is 2.55. So you look for 2.5 and it goes up to 5. Look at this point here. Here is 2.55. Over here is how much? 8, 10, and so forth now. Oh, by the way, in the exam, the points, we're supposed to put the values next to it, the x and y coordinates, even for the cumulative frequency. Not for the histogram, but cumulative. You see, when you're plotting points, you're supposed to put the value next to each point. So do me a favor now, right? Put in the value of each point, right? Now, for this one, you don't have to connect it to the origin, right? You don't have to connect it to the origin, right? Now, if you decide to, nobody going to do you anything about it. But to me, it really not necessary for this one, okay? And this one, you have to use a ruler. The frequency polygon is the one where you have to use a ruler. All lines must be perfectly straight. How much people got full marks for this particular diagram? Look at my graph, compare it to yours, make sure it's okay. Right. So a few people said they missed a few points. Just take a few seconds, correct it, right? I really hope you all get the frequency polygon. It's the easiest out of all of them, right? Right, so let's go on to part, right? The modal class. Well, you all know this one already, right? The modal class is the one with the highest frequency. Which one had the highest frequency? And 15 was the highest frequency. So it was the 10 to 15 hours. I suspect nobody got that wrong. Please tell me you didn't get that wrong. The actual answer is 11 to 15, the one that contains the highest frequency. No, the answer is just 11 to 15, not 13 point anything. The modal class, right? Modal class. Now, just now, no, I don't think I did it wrong. Just now, highest frequent, and have a higher number than 15. No, 15 is the highest number. I'm pretty sure it's 11 to 15. All right, let's move on. Calculate the mean of the data. Now, it's just like how much people got this one correct. Notice you had to use the midpoints, and you're going to use the same formula. Guys, I want you all to compare your working to my working. Make sure you have the same exact values. Make sure that when you add sigma fx, when you add up all, instead of it being vertical, I did the calculations horizontal. It could come like that in the exam, right? Take a couple minutes, please. I just don't want you to shake your head and say, yeah, I have that. Make sure you understand all my working. When you're sure, send me a message saying, all right, good to go. Right. Determine the probability. Anybody was able to get the probability as 0.4? Now look at this here. The probability, right? Remember, probability is what you care about divided by the total. So the question is, determine the probability someone chosen at random spent more than 15 hours. So now, more than 15 hours does not include 15. So people who spent 16 to 20, 21 to 25, and 26 to 30, those people fit the criteria, right, of studying more than 15 hours. So how much people is that, right? That's 12 people, 6 people, and 2 people. So if you add up those values, how much you're going to get? 20. So the total amount of people that fit our criteria that we care about is 20. And how much people do we have in all? If we add up all the people, we're going to get 50. So 20 divided by 50 is 0.4. Let's go. Also, I didn't prepare this one, guys. Sorry, I didn't prepare that one for today. I forgot for this one here. That's all. I want to just find out something.